So in my case, I built a shed. You want to find something that's semi-outdoors. You don't want to install this in the direct outdoors. So the shed I built looks something like this. There's the door, the entrance. And just show you the entire thing. That's the front side, just the bare wall. And then I have a air vent, a makeup air vent for the UNI boiler, and that's what this big thing is. And let's look at the roof. So in this case, we have the vent. So as you can see, this has got enough room for the UNI boiler. In mine, each of those tiles is approximately 1 foot. So we have 1, 2, 3 foot wide and plenty of room in the depth. And even when I install the UNI boiler, I'll have enough room for that door to open. The only other thing that's in this shed is a baseboard radiant heat, and that is just to keep it from freezing. And the other thing, a roof penetration for the flue. Now the kind of pipe you want to use, I'm using Duravent, and this is a double walled. And once I get it past the roof, we're going to put that on the top. That will be the cap on the top, and that will seal it once we get the cap on. The other thing you're going to need is this makeup air vent. That is, remember, it came from outside. And so that basically just brings fresh air from the inside, goes through this, which is essentially just it's just cutouts, and then I push those in. It allows air to flow here. And the same thing on the bottom. We have an airflow there. The third thing you're going to need are the pipes. So for mine, it's a feed and return. So these pipes will go into the wall. One will be a feed, one will be a return. Inside the wall, I'm going PEX. Outside the wall, it's copper. And then inside here, these pipes will be insulated for heat loss. And those will go into my boiler room, into the house. The last thing you're gonna need is a 20 amp breaker. This is just a regular square D 20 amp. You could go 15 amp. I went 12 gauge wire, so we have the 20 amp. This also powers the heater. The power is the heater down here. And the other part of it goes into my box. Now inside the box, we have not only the wire for power for the unit, but we also have a signal wire. This is what's going to control the pump of the boiler. So the next step to installing the boiler is obviously getting it into place. Normally, I don't recommend doing this by yourself, but I have no choice in the matter right now. So I'm going to try it this way, and I'm going to try to get it on that lip. hung up right here. Should have saw that coming. All right, she's in the shed now. I just gotta scooch it in place. So there it is. It's now kind of situated where I want it. So let's look at it. And it's a double wall vent. You have the interior wall, which is stainless steel, and then you have an outside jacket, which is usually galvanized. And from everything I've heard, it's really the best option for wood burning fireplaces and the sort. And also the 6-inch vent fits perfectly onto the UNI 15 right here, almost as if it was made for it. And all I have to do is secure that into place, and then I'll start working on my flue. Before I do that though, I want to level the boiler. You can see the way I have it situated. It's not quite level. I need to shim it from the bottom, so I'm going to use these metal shims, and I'm just going to shim it underneath. And as you can see, there's a little eyelet here that you can also drill a hole through and mount it to the concrete. So after we shim it into place with a bunch of metal shims, so here on the roof, down below, we just pop that through. One thing about DuraVent, you always have to remember to look for the label. It's not on this one up here, but it's probably down below. And always make sure that the arrow points up. So, and that'll make sure your flue gases are escaping properly. You can see the arrow going up, and that's going to be kind of hard to mess up. Let me put this camera down so you guys can watch this happen. Okay. Okay. And then the skirt will go on right after that. And basically this will just cover up all the openings that were left over. We're going to put that one in the little slot here. Back out. Use my gloves for this. And then we're going to fold this over. That'll secure it. And I'm going to leave it like this for a second, just so I can get the caulking on it. I'm going to seal it all around. the rain out of my shed. Now you want to use a high temperature caulking, something about 300 degrees minimum. If you got that, then it won't heat up and start leaking. Okay, now I can fold this over, no problem. And I'm just gonna smooth it around, make sure it's all sealed. And that's essentially it for the flue. The rest of the installation is all inside. So we can get out of the rain now. But I wanted to point this out really quick. As you can see, after leveling it, it's perfectly level this way. And then we also got it level this way. You just want that bubble right in the center. Check it on all four sides. And looks fairly level there. Probably tiny bit off on the back, but the sides are pretty square. Another place to check it would be like right here, just to make sure that there's no bows in the sheet metal. And it's looking pretty good. You want it level because you have fluids going through there. You don't want air gaps and air pockets. You just want everything to work the way it was designed. So let's look at the UNI 15 itself. We have 3 compartments. So I'm gonna, just to get familiar with the unit, you should as well. The top one doesn't really serve any purpose. This is more maintenance for cleaning the flues. These are probably going to get coated with soot. This looks like a stainless steel box that collects all the water and does most of the heat transfer from the biomass and whatever you're burning to the fluid that's going through the UNI boiler. In back of this flue, if you look straight out, that's the flue pipe. I don't know if you can see it, but if the flue pipe wasn't there, you would see light through there. So this is essentially just an access for maintenance and cleaning. So that's probably not going to be used a lot. The second one is your hopper. This is where you load your fuel. And you can see it's got a little ramp there just to load all the fuel. So in back here, your inducer motor sends fresh air through this chase right here. It basically blows it up, and you want this stop to stop the flow so that it will stop here, and then obviously most of the air will fan below that through these little slots. This would be adjusted depending on the height of your load, how much wood you put in it. If you put just a little bit of wood, you're probably going to want it right here. If you got a lot of biomass that burns quickly and you want to fill your hopper up full, then obviously this is going to go higher. So what that does is, as your inducer motor is blowing fresh air, it just blows below it and obviously fans your coals and gets your flame to the maximum temperature. So that's the hopper, and that's essentially all you have to know for that. The bottom bin, we'll look at it. You've got this metal firewall, and this folds down. This is and exposes your burn chamber. So essentially this is where you're going to want to start your fire, get your kindling going, get your coals hot, and then you can obviously load your fuel after you have a good bed of coals. Below that, when the coals get small enough and they start turning into ash, it fills up this area. And the UNI 15, they provide you with a little catch pan for your ash, so it makes it fairly easy to set that below there and then scoop out all your ashes, and then either toss them in your garden. They actually make really good fertilizer. So that's essentially it for this. We're going to move on to the plumbing and mounting the sensors, and then getting a little familiar with the electronics in it. So you've got a couple ports. This one is going to be used for a sensor, and that actually detects the temperature of the water inside the boiler. Or I could say load out is probably terminology, because this is essentially the hot water that's going to feed your load inside the house. Now in back here, we've got 3 more things we're going to have to connect. The little 3/4 inch pipe right here is where you would attach your pressure release of my shed. I'm going to drill a hole through the tile. It's better to have the glycol leave the shed instead of flooding it. So I'm going to put a pressure release valve there, and then angle it down and send it straight out into the outside. This is the return. This is where the water comes in after the load, and then it circulates through the boiler. This little open is for your inducer fan, so we'll mount the fan here. And obviously what I'm going to have to do when I get the copper, I'm going to have to route that around the inducer fan and then out to my house. So essentially that inducer fan is pulling air in and going up the chase like I was just describing. The reason for that is obviously to fan the fuel and keep it burning. And because of that, that's the reason I had the makeup air, the 8-inch makeup air vent installed into the shed. That way you have makeup air that's available for the inducer motor. So the first thing I want to do, as far as plumbing goes, I want to install a pressure release valve. Now this is just a pressure release valve. It releases at 30 psi. I could use a pressure temperature release valve, and that would release the heating fluid if it had too high of a temperature or if the pressure was too great. I believe we only need a pressure release valve, because if the temperature is too high, you don't want to lose the heating fluid, because that would greatly increase the temperature. So instead of putting a dual, I'm just using a temperature or a pressure release valve. That way, if there's too much pressure in it, we're going to have a release in the pressure. Now, I'm just going to screw this on temporarily, because what I want to do is I'm going to have this go down a little bit and then shoot out that wall. I just want to know where I need to drill my hole. Okay, I'm going to do a real quick video on how these pipes are cut. When you're cutting large diameter pipes, such as this one, you probably want a really beefy pipe cutter. This is a rigid. It goes up to 2 inches. So we got 1.5 inch pipe, and one of the lengths that I need is 4 3/4. So it's real simple. You just want to line the cutting wheel to the tape measure at 4 3/8, and then you just slowly tighten the handle until she bites. And from here on out, you can assume all the cuts are made this way. Get it kind of snug. And then as you turn the wheel, it's making a slight scratch on the pipe. What you want to make sure is that that wheel and the cutting wheel intersect so it doesn't thread. So one way is to go one way, then the other, just to make sure you don't have any threads. Once it's got a groove, then it doesn't matter. You can go either way. You just take that cutter, go around, give it a snug tight, go around again. Now this pipe is L, so it's going to take a while to cut through it because the wall is thicker than, say, M. Oh, there it goes. You'll notice on these, this cutting wheel leaves a little edge on the pipe. That's not a huge concern. I always take a reamer and get rid of that. Just go through like this. Takes off that edge. That reduces turbulence inside your line, and especially here, you're going to want all that turbulence to be. You want the flow to be laminar. You don't want any turbulence in that line. So I just take off the burrs. So now we have 1.5 inch diameter, free flowing. So as far as soldering, first thing we want to do is we want to score the outside of the pipe where the soldering is going to take place. Usually use an emery cloth. For this one, we just can just wrap it, go around a couple times until you see nothing but clear copper. Now the solder is going to the actual joint part is right there in the bottom, so you want to make sure the end is really scored well, and there isn't anything on the end there that can pick up debris where the solder won't adhere. So we want to make sure that's really. We're going to score the inside of this. And then we're going to go ahead and put some flux on both sides. So we want the outside of this pipe, and you want to just make sure you coat the whole thing. That way, so the flux really draws in the solder. So we want to make sure it's everywhere. Not too much, but you want to make sure it's there. And then you just put the two fittings together. Snugger the better. But you want it all the way seated, all the way down to the end. Now this is going to go on that piece of pipe, and I'll show you the sweating process. With sweating, you want to make sure you heat everything around. You have to also remember that solder follows heat, so keep your torch towards the end because you want to draw the solder into this side of the fitting versus the outside. You don't want just a ring of solder. You want it pulled all the way into this joint, and you want the ring on the back of the fitting. But basically what you want to do is you want to get this fitting hot all the way around. These are L fittings, so they absorb a lot of heat. So it's going to take a minute or two, and then once it gets hot, then you can start to get the solder going. But you want to make sure this thing is really hot, and I usually start from the back. I want to get this really hot here. You can see all the flex is starting to drip off. A little more flame there. Now normally I use acetylene, but these MAP gas torches are really convenient when you're trying to get into tight spaces. You don't want to get the solder too hot or the copper too hot, but you don't want it you want it hot enough to sweat though. So let's go ahead and just get this sucker warm. see it's starting to turn colored, so I want to back off with the heat a little bit because we don't want it to, we don't want to heat treat the copper, obviously. We just want it warm enough to start soldering. And I'm going to hit the top a little bit just to get this starting to flow. And there she goes. Okay, once you get it all around, how the threaded fittings fits on and we get it to seal. Now, what I did is I soldered this before we put the thread on because that way the heat, when I'm soldering above, is far away from the thread. However, I have many times soldered it right on top of the thread like that, and it doesn't really pose any problem. Now, you may be wondering, why am I going copper here in the shed? And then I'm transitioning to PEX inside the wall. The reason is that PEX is very resistant to UV. In other words, if it were in the sunlight for any length of time, that means opening the door or whatever, it will damage it. Now, what's going to happen in this shed is this wall is going to get closed up and tiled over, and it's going to be completely dark. So PEX inside the wall is not a problem. PEX outside the wall would be a problem. So this is all going to be copper. And again, it's going to be inside insulation, so it probably wouldn't matter anyway. So I'm going to try to set this camera up so you can kind of watch me do this. First thing you want to do is use a pipe dope. This is a pro pipe dope. There's many different types. Just basically a thread sealer is what you want. Now you want to get it in around the joint, but you want it to, you don't want any bubbles inside the thread. So you want this stuff to really get in there and really coat the threads. Essentially no bubbles in the thread. You want the pipe dope all the way down into the bottom of the thread. And we want to go all the way around because the last thing we want is a leak. Now, once we solder it, there's no more turning this or tightening it unless you put a swivel on it. So I like to do it correct the first time. So once we get that fairly gooped up, we want to go with thread. Now, the thread, the way you want to wrap it is this way, counterclockwise. In other words, when I tighten the fitting on top of this, it won't bind up the thread and unravel the tape. So it basically goes on this way. We want to do at least 5 loops. That's 1. And kind of keep it tight. 2, 3, 4, and 5, minimum 5. I'm going to go 6 just for the heck of it. And the other thing is obviously we're going steel to copper, and that might bring up the question, why are you going steel to copper without a dielectric coupling? Just my experience, dielectric couplings have more problems than steel to copper. I've done maintenance on these, and every time I take apart a dielectric coupling, it's got all kinds of leaks to it. But I have never had a leak in a copper to steel fitting from corrosion, and I've never found corrosion on the inside of them. So my experience tells me that it's you know, a lot of plumbers will say you need a dielectric or a dielectric nipple. However, just experience in the field tells me that it's not really necessary. And you rarely see that on boilers where you have a steel copper connection. Rarely do you see a dielectric. So they're all over the field. I don't really see a problem with it. Some people might tell you differently, but I've been doing plumbing for 30 years, and I've found that this connection doesn't pose any problem. So we're gonna get some torque on this guy. Make sure that sucker's in there really tight. Now that's not gonna leak. So we're gonna fast forward the rest of this. This is the inducer motor, and that mounts on the back. And this is the motor that blows fresh air across your burn chamber. So that one mounts in back here, right into this area with 4 screws. You can see I left 2 screws in because they're slots, so I'm going to slot it in and then put the other 2 screws in. Do not, there's 2 ways this could be mounted. You could mount it this way, or you could mount it this way. Make sure you mount it this way, because this has a little damper in it that's gravity fed or gravity operated. So it needs to be in this position for this to work properly. So now we're gonna put this in. So I don't know if these actually come with a gasket. When I looked through all the components, I didn't see one. So instead of crying about it, what I'm going to do is I'm just going to go ahead and silicone the outside, give me a seal, because you really don't want any kind of fresh air escaping. You want that to be somewhat pressurized so it goes over your firewood or your whatever kind of stuff you're burning, or your combustibles. So I'm just going to seal this, and then just the inducer fan simply goes in like that. Kind of center it. Need at least 1 screw on this side to hold it in place. Once you get these started, then there's 4 screws to tighten. Looks like I'm going to need an extension on that one. This one looks like it's hitting something. Let's see if there's a better way to get this started. There it is. Okay. And then I'm going to need an extension for that one. I'll go grab. Okay, so now I got the extension to get into that last one. Alright, and that's sucked in well. Okay, so you can see that's gravity fed. This simply has one plug-in. This plug-in will plug into the controller, and the controller will operate whether it's on, off, or how much power goes to it. So the electronics that come with the unit are this thing, which has a plug-in on one end, a plug-in for the United States, looks like a 110 plug-in, and then you've got a bunch of wires on the other end. And as best I could tell, now I have plugged this in and ohmed out these wires, and I expected to see 220 across here and having 2 hots and a ground. However, that wasn't the case. This ended up being 60 volts across here, and then when I go from a hot to a ground, it looked like about half that, about 30 volts. So that didn't work that way. I'm assuming this, you're supposed to charge this with 220, and then this side would power the 110. However, you never want to power the plug, you want to power a receptacle, so that would make it backwards. So I've decided that this is probably a dangerous thing to have, because it would mix your wire up, and it's so much easier to do things with relays and just use the power source that you have in your house. So I got rid of that. I don't know why it should even be a part of this thing. So let's talk about the electronics. You have this this thing which fits into your housing with 2 screws in the back, and that just pulls it snug. It doesn't have a top. The top is actually the casing here, and that will fold down. This cord is the signal cord. Obviously when you flip it up, that's on that side. This is the signal cord which fits into your display, your LCD display. So the cords that are obvious, this one, and I have applied power to this, and it takes 220. This is European. It's expecting, I believe, 240, 50 hertz, but we only have 220, 60 hertz. That still works. When I charged it with 2 hots, it does power up the unit. This is a ground, so because this plug-in is useless to us, what I'm gonna do is I'm gonna cut this, strip the wires back, use a wire clamp, put this in my junction box, my electrical box, and that'll be my power, and then I'll have a switch to turn that on and off. This thing is also fairly obvious because that's a flue sensor. It's got the stainless steel cable so it doesn't corrode. It's pretty obvious that goes into the flue and detects the temperature of that. Then you have 2 more water sensors, and then you have a emergency overload sensor. This is the plug-in for the inducer fan. So that goes into the fan that we mounted just a little while ago. This is the overload sensor. This will be attached to the pipe, the load out pipe, as I called it. They call it different things in your pamphlet, but this sensor will be attached to the load out pipe. Just they want it within 10 centimeters of the boiler. You've got 2 outputs. These 2 are, you've got a ground, and then they use heat shrink to kind of protect the hot and the neutral. And that's for your charging pump, and the other one's for your domestic water pump. So these 2 sensors are going to be, one is for the well that goes right into your boiler. The other would be for your domestic hot water if you need that. For my application, I won't need it. But here's something that helped me quite a bit, and this is in the pamphlet that comes with your unit. It's a TIS Electronics 260. You're really going to want to pay attention to page 21, because in it you'll see essentially the circuit board in a diagram. That's this thing. And in the circuit board, you can see that all the terminals are labeled like that. That one's I1. This one is T4. You have your Qs, your Q2. All these are labeled, and those also correspond to and they're exactly match up to these. So your I1, your I2, all of those are essentially what you're going to see on the circuit board. So if you ever get confused, all you have to do is find out what is wired to I1 and then look down and say, okay, I1, that's the emergency thermostat sensor. So that will tell you, if you follow it back, like that's the I1. If you follow it back, the green or the brown wire, that is this sensor. That's how I knew what sensor this was. So that's gonna tell you how to place the sensors where you want them to go. Now the next page kind of shows you where everything goes. So you have your electronic sensor, that's your domestic hot water sensor, so that's going to be one of these. One of these will go in your domestic hot water. You're going to have the other one, the second one that looks just like that will go inside the well. And then that emergency thermostat sensor, this one, will get tied to the output line on the boiler right there. The last sensor, of course, is the flue sensor. That one is pretty obvious. That one goes into the flue, and we screw that one in. And so that's how the controller will get the inputs it needs to decide when to turn on the pumps. The pumps will be turned on by these. So you saw on mine, I had a 18 gauge low voltage signal wire that goes to my boiler. So what I'm going to do is I'm going to put a relay that takes in a signal of 110 or 110 volts, and it opens and closes a switch, and that switch will go into my boiler through those 18 gauge wires. It'll either be open or closed, and that will turn on or off my pump inside the mechanical room. The reason I did that is because I don't want these wires, because they're European. I wasn't sure if they'd come in at 220 with this kind of wiring that's really not up to the standards in America. So I didn't want to run that through my house. So I decided to use signal wires and a relay on this end and a relay on the boiler end, and that will work just fine as well. Okay, so given the chart, I looked at it and I found out that this sensor is the domestic hot water, and I also kind of saw these symbols on there. They're obviously in some other type of language. I don't know what it is, but a backwards C, a backwards B, and a backwards J is the domestic hot water, and that works on both of them. The other one for the boiler is, well, this one doesn't say it, but the boiler pump, if you look at the domestic hot water pump, that also has that lettering, the backwards C, the backwards B, the backwards J. And that is, as you can see, I labeled it domestic hot water. The other pump has some other type of lettering on it. Looks like an O and maybe a U. And that one's for the charging pump. So I went ahead and labeled them. So now that we have everything labeled, I'm going to connect this to the UNI boiler. Before we do that, we need to look at this electrically so that we know that what we're putting in is not going to be dangerous. This appliance, it was made in another country, and the electrical codes in America are very different. So the power coming in, this is a fuse, so I know that any power coming in that has an amperage greater than this fuse is rated for, then it will kill the amperage. So I'm not too worried about these thin wires because this fuse here protects them. So the two wires I have coming in are a blue and a brown, and these are my two hots, and that comes in from my junction box. And then I have a power switch here. The other wire is a ground. So this wire, because it's a ground, we need to also ground the unit itself. And as far as I can tell, the outputs are also 220. because they have a blue and a brown wire. And I'm assuming they wired this color code correctly when they wired the circuit of the circuit board. So you can see this one is for the inducer motor. It's got a brown and a blue. And this is for the CH pump, and this is for the domestic hot water pump. And they both have all of them have a brown and a blue. So I'm assuming we're getting 220 volts as an output. The manual says that it's a line and a neutral, so I think that's a mistake. When I looked at the this, you can see on the Q1, Q2, it says line and a neutral. That implies that it's 110, but I believe it's actually 220 because there is no neutral. The power cord that was provided with this unit has two hots and a ground. There is no neutral. This I believe is a ground too, or just a clip that holds the case together, because coming into this box we have two hots and a ground. So this ground has to ground the UNI boiler as well. So what I'm going to do is I'm going to put this on the circuit board, just a parallel connection. I removed the connection they gave us, and I put this one in parallel, and I'm going to attach this one to here, and then I'm going to have a grounding wire come in, and I believe I'm going to use this. Oops. I'm going to use this open port that they have as a ground terminal, and then I'm going to connect this ground to here. This bare copper wire, I will then ground it to the UNI boiler, probably using one of these, get yourself some grounding screws. So you want to replace this screw with a grounding screw, make sure it's the same size. If not, you're going to have to find a place to set a grounding screw. So essentially what I want to do is ground this boiler so that if there's ever an electrical short inside the box and it shorts onto the casing, it will automatically ground, short out, and trip a breaker versus shocking me. So that's kind of an American thing. It looks like in Europe they don't do it. Here we do, so that's how it's going to get wired. So that's a modification. You can see the grounding wire that they had originally still goes into the circuit board. And then we have another ground, which is a bare copper wire, which I'm going to use to ground the unit. Okay, so now we have the ground wire coming out of this. I have all my wires labeled, and I have a ground, and I'm going to attach that to the UNI boiler, and then use my grounding screw to make sure that the unit's grounded. You'll see two tabs on the back. So you want to make sure those set inside the sheet metal. This goes straight down. And then this cover, the connection is just a network cable. Orient it where it's facing upright. Those can just go in there. And then this slots in here. Now the two screws that hold this in place also hold this from coming up. So let's go ahead and set those in. Okay, so she's in. And I also checked on this motor. It looks like it runs off of 220 volts as well. So I'm very sure that those outputs are 220 and not 110 as the instructions would suggest. So the inducer, this came from the controller. This is the inducer fan. That one just pretty much plugs in. So now that ground screw is in and we have this thing mounted correctly, you can see the display is correctly mounted. Now, one thing I didn't talk about, which I probably should mention, The UNI boiler comes with this blank cover, and if you remember, there was a network cable that plugged into the back of this. If you wanted to, you can add an extension and route that network cable inside your house, and then bring this display inside your house and mount it on your wall or something, and then use this to cover the opening. Either way is fine. That way, if there's a problem with your wood burning boiler, you can be inside your house and find out. I don't really see any advantage of that. I like to have the display where the UNI boiler is. That way, if I need to adjust something, I'm right here. The ground wire, I used this port here, and I replaced that screw with a ground screw, and of course that goes into the circuit board. So what I'm going to do, I'm going to go ahead and cut this European plug off. I'm going to use a cover and a wire clamp and send the wire through into that electrical box. And then I'm going to use my white wire as one of the hots. So I've got the black wire as a hot, a white wire as a hot, and obviously you want to wrap it with black electrical tape just so someone else knows that that's a hot as well. And then I use my bare copper wire as the ground, and that's the only 3 wires I have on this thing. The 18 gauge here, I'm not going to send 220 through this. What I'm going to do is the outputs, which are 220 as we just determined, and then that 220 output will control a relay. That relay will become an on-off switch, and that on-off switch will go through the signal wire. So that's just going to be an open closed. I'll probably send 24 volts VAC through this signal on the boiler end, and that 24 volts will activate another relay which will power my pump with American Power, which is 120 volt VAC versus the 220. It would be too dangerous to send 220 volts through this 18 gauge wire. So that's the reason for that. And I don't want to send 220 European style wiring through my house. So that's the kind of the logic behind that. This is 18.6, so I've got plenty of wire. I can do 2 signals, 2 for the domestic hot water and 2 for the charging pump. Simply, this is the one for the boiler. It simply goes into this well, goes straight down into there till it bottoms out. Do not put water in there. So this was a little difficult to show with one hand. So the flue sensor, that's a 1/4 inch hole. I'm just going to insert that and then secure it with some sheet metal screws. So now we have our flue temperature sensor installed. We're going to attach the over protection, or when this over temperature sensor onto the load feed, or the load out pipe. Okay, so we want this fairly close to the, and I'm using zip ties. You can probably use electrical tape, that would work as well. But I want it almost to the bottom there, as close as I can get it. I'm going to zip tie the top as well. Just something there that whatever that temperature is, it's gonna pick it up. 3 wires left. These 3 wires will be one is going to be the sensor for the domestic hot water. One will be the output pump for the domestic hot water, and then we'll have the charging pump output. These two outputs will go into the electrical box and will be attached to the 220 relays, which will just send signals, on and off signals, through my 18 gauge wire that you saw in the junction box there, right up there. Remember, that's 18.6, so I have 2 for the domestic pump on off, I have 2 for the charging pump on off, and then I have 2 for the sensor, because this sensor needs to pick up the temperature of my domestic hot water inside my boiler. This needs to be extended, so what I'm going to do is I'm going to cut it. I'll wire it to 2 of those 18 gauge wires, and then I'll take this end and attach it in my boiler room, and that will go into my hot water heater. That way I pick up the temperature of that, and that'll send all those inputs back to the controller, and it'll decide when the output is necessary.